Alright, what's going on, my band peeps? We've got some new stuff that I want to show you guys today. Hopefully you guys are doing awesome at state, having a good time, trying your best. Good luck with that. If you guys aren't done yet, continue to perform well and make us proud. But let's take a look at some of this pre-cal stuff. Here's some older stuff, so some review of some of the inverse trigonometric function things that we've done. Something I wanted to really emphasize and something I wanted to remind you guys is that when we're taking these inverse trigonometric functions, we're inputting these values, like in this case, -1 into cosine here on 13. We're inputting -1 into the inverse cosine function. The output is an angle. Okay, so whenever you're taking, you're evaluating one of these inverse trig functions where you've got some value inputted, the output's always an angle. So be careful when you're going through that, so that you remember that a lot of times your output's going to be an angle. Whereas if you have a regular function like 19, the output of that's going to be a value, whereas the input is an angle. So it's kind of the back and forth of it. So go ahead and I'm going to go ahead and do the evens. That'll leave, or sorry, the odds. That'll leave you some evens that you guys can try out on your own. But here at 13, you get the inverse cosine of -1. So basically, the angle where cosine, the value of cosine is -1. Well, there's only one place that can happen, and that's at pi. Okay. Let's see. The inverse cosecant is -2. So if you remember that cosecant of some theta is really just 1 over sine. So really what we're thinking about is, here being -2, really what we're thinking about is what angle would sine, really it would be the same as sine would be -1/2, where we're just kind of flipping things. Okay. The negative inverse sine and tangent, those ones come from the fourth quadrant. So what we'd be looking for is, where is sine 1/2 in the fourth quadrant? Well, it's going to be a negative angle because we use negatives there. And then that's just pi over 6. Okay, that's where sine is 1/2. Cotangent inverse is square root 3. So square root 3, again, cotangent theta is just 1 over tangent. So usually, if we were to flip this guy, this would be the same as the tangent inverse of root 3 over 3. Because that's what happens when you flip root 3. They just switch between each other. So really we're looking for these two. Well, 3 plus 3 is 6, so that's the pi over 6 family. So pi over 6. Okay, cotangent is just that one flipped. Okay, so cotangent is going to be the opposite. 3 doesn't add up to 6, but that's because it's cotangent. Okay, so now this one. These more complicated ones. Got to work inside out. So we got to do this thing on the inside first, and then we can work our way out. So we're tangent of inverse sine of root 2 over 2. So we got to do this inverse sine of root 2 over 2 thing first. The only place where we have root 2 over 2 is just pi over 4. That's our pi over 4 family. And being that's positive, it's going to be in the first quadrant, because that's where we're limited. Now we can do the outside. We can work our way out. This was pi over 4, so now we can do tangent of pi over 4. Tangent of pi over 4 happens to be 1. It's kind of the easier one to figure out. So those are just like our racking our brain on some of the stuff that we've been doing so far. So now let's get into something new. Flip over to the other side. It comes down to some identities. So the idea here is that some of these things we know, like tangent is just sine divided by cosine. Okay, so we should be able to know that one. Cotangent is just that flipped as a reciprocal. So it's just equivalencies. It's just saying that this thing is equal to these things. So I could easily substitute between a tangent and a sine divided by cosine. That's kind of the idea. Okay, this is how these identities and simplifying trig identities, which is what this is called, that's kind of how it works. It's taking advantage of these relationships so that we can simplify expressions. Over here, these reciprocal identities, we also should know these ones. Secant is 1 over cosine, cosecant is 1 over sine, cotangent is 1 over tangent. They're not new. Right? And we can reverse those. Cosine is 1 over secant, sine is 1 over cosecant, tangent is 1 over cotangent. That's not so bad. Where we get a little weird, and I could probably make maybe a 15 to 20 minute video alone on how to prove these kind of identities, is where we get these funky little identities over here. Sine squared theta plus cosine squared theta equals 1. it works. It's a Pythagorean identity. You use Pythagorean theorem to prove it. I don't have time for that, but it works. Okay, using some of the quotient identities, these ones from up here, and reciprocal identities, you can actually change that first one into these other ones. You got tangent squared theta plus 1 equals secant squared theta. You've got cotangent squared theta plus 1 equals cosecant squared. So those ones work. Now, what's nice, I know you're probably like, what? But these identities are going to be given to you. You don't need to memorize them. Okay, you're going to have a whole sheet. Okay, the whole time you're going to be using these things, you're always going to have this sheet available to you. It's really just going to be applying them is the most important part. Okay, how to use them. So no better way than just to jump right in. So over here we've got, it says use your trig identities to simplify completely. Okay, that is very vague, and I know. Like, when am I done, right? So here's the step, here's the process. When you got something like this, you're looking at number 1. Change it to sines and cosines. Literally just do your best to change it to sines and cosines, and then go from there. Things will start to cancel, you'll notice patterns, and life is good. You got these squared things. When you have the squared things, use your Pythagorean identities to try and manipulate them so that you can make it so things cancel. Okay, you'll see. Trust me, it just takes some time. Seriously, just absorb this. Okay, don't check out. Just watch and learn. Okay. Let's see. Number 1 here. I want to take advantage, and I can actually, let's zoom out a little bit so we can see my identities too. So there's my quotient identities at the top. So I'm going to be using those ones. Tangent. Well, tangent is sine divided by cosine. So again, just if there's no squareds or anything, just change them to sines and cosines. So tangent, and I'm just literally going to change everything. I'm going to say that's sine theta divided by cosine theta. Okay. Then that's times, and then I've got, and I'm actually going to make a fraction out of cosine too here. Cosine theta over 1. Okay, you can put anything over 1, and it has not changed. Okay, so that's good to know. Times, so I've done this thing, I've changed cosine to cosine over 1. Cosecant, remember cosecant over here is 1 over sine, so I'm going to change it to that. So literally all I've done is just change everything to sines and cosines. 1 over sine is my cosecant, so sine theta. Okay, now looking at my fractions here, I can start to cancel things. Look at this. I've got a cosine on top and a cosine on bottom. Boom, those are gone. Okay, a sine on top and a sine on bottom. Boom, those are gone. What's left? Nothing but 1s. 1 over 1. Well, what's 1 over 1? 1. How do I know I'm done simplifying? You can't get it any more simple than 1. Okay, that's kind of the idea. Alright, so that's our one type of problem. It's literally, if there's no sines and cosines, we're just, all we're doing is we are just changing everything to sines and cosines. We're canceling things out, and life is good. Now, when we get to these types of ones, where we've got some squareds, so I've got a cosine squared, I've got a tangent squared, I'm trying to fit them into these Pythagorean identities. I'm trying to figure out if I can make them into a way to where they're like this. Now, ways that they're going to trick you. 1 plus tangent squared. Check this out. Tangent squared plus 1. Those are the same thing. Okay, you've just flipped the order. So right here, this thing right here is literally just secant squared theta. See these equivalencies? Tangent squared theta plus 1 is secant squared. So that means that 1 plus tangent squared, which is the same thing, is just secant squared. So there's a secant squared. Okay, cosine squared, just going to leave that. Let's leave that be for right now. Okay, we'll just leave that alone. Remember, secant squared, well, secant is just 1 over cosine, right, from up here. So that means that, really, well, let's leave cosine squared alone for a second. And actually, let's put it over 1, just because we can. Let's change this to cosines. Secant squared would be 1 over cosine squared. Ooh, look at that. I got a cosine squared over a cosine squared. Cosine squared on top, cosine squared on bottom. They gone. We got nothing but 1. Again, how do I know I'm simplified all the way? Nothing more simple than 1. Okay, you're just trying to cancel out as much as you can. That's the idea with these kind of identities. All right. All right, let's keep going with these things. Let's take a look at these guys down here. Again, I'm going to zoom out actually so we can still see my identities as we're going. Yeah, there we go. Okay, here's this one. 1 minus cosine squared theta and a 1 plus cotangent theta. So here, again, we got squareds, so I want to be looking towards my Pythagorean identities first. So here's the thing. Just because the identity looks a certain way, like right now, doesn't mean I can't change it. So right here, if I look at sine squared theta plus cosine squared theta equals 1, let's manipulate that a little bit. Let's get sine squared by itself. So here, I'm just going to do that in the middle here. So sine squared theta plus cosine squared theta equals 1. What if I wanted to get sine squared by itself? Well, I would need to subtract cosine squared from both sides. So cosine squared and cosine squared. So I'd subtract cosine squared from both sides. Then I'd have sine squared theta equals 1 minus cosine squared theta. Well, hey, looky there. 1 minus cosine squared theta. Okay, I made a completely different identity right there. I've got sine squared theta equals 1 minus cosine squared theta. So here's 1 minus cosine squared theta right there. So there's an equivalency right there. Sine squared theta. So this guy's just sine squared theta. So I'll just write that. Sine squared theta. So that one just changed into that. Okay. Now 1 plus cotangent squared theta. Well, that looks familiar. That's like that one right there. There's our cotangent squared theta plus 1. So again, it's the same thing. They just flip sides. Okay, so this guy's just cosecant theta, or cosecant squared theta. Maybe you can see where this is going. Cosecant squared theta is 1 over sine theta. So that means, let's rewrite this guy, sine squared theta over 1. Okay, so it's like a fraction. This guy is just 1 over sine squared theta. And again, looky there. Things have canceled. I'm left with just 1 over 1, which is 1. And again, that is how I know I'm simplified. It's very much simplified. Okay? Let's start with these last couple here. Cosecant theta times tangent theta. Okay? Again, no squareds. So there's no squareds. So what I want to do with that one is I want to go ahead and just let's change them to sines and cosines. Cosecant is just 1 over sine, so let's change that one to 1 over sine. 1 over sine theta. Tangent is my quotient identity, sine over cosine, so that's just sine divided by cosine. Right? So there's sine divided by cosine. Let's see what we can cancel. I've got a sine on top and a sine on bottom. So that's sine on top, sine on bottom. Those are gone. What's left is I've got a 1 over cosine theta. Okay? 1 over cosine looks pretty simple, but I can actually make it look even simpler. What's 1 over cosine? Secant. So this is just secant. Secant theta. There you go. Can't get any simpler than that. Okay? In math terms, secant theta is more simple than 1 over cosine theta because I got rid of this nasty little fraction here. So now I've got just a secant. That's as simple as I can get. I can't cancel anything else out. I've made it as simple as I possibly can. And then there we are. Here we go. Here's a fun one. Secant theta plus 1, secant theta minus 1. Now I know it may have been a long time, but maybe you've seen something like this. Just to throw it out there. I don't know. Maybe this x minus 1, x plus 1 thing. This is called difference of two squares. So if you were to FOIL this or multiply, use the box, whatever you do, you'd end up with x squared minus 1. So it'd basically be x squared, so this first thing squared, and then this minus the second thing squared, which is 1 squared. Another example would be like, oh, I don't know, y plus 9, y minus 9. It's just the first thing squared, so y squared, and then it'd be minus the second thing squared, so 9 squared would be 81. All right, cool. How does that help us? Well, it helps us like this. Secant and secant, that's like my x. 1 and 1, that's like my 1 and 1 over here. Okay, so this would just be our first thing squared, secant theta squared, and then minus 1 squared, which is just 1. Secant squared minus 1. Well, if I look up here, I don't see a secant squared minus 1, but I do see a tangent squared theta plus 1 equaling secant theta. What if I wanted to get tangent squared by itself? Well, I could do the similar thing that I did to these guys. I could go tangent squared theta plus 1 equals secant squared theta. How about I get tangent by itself? I would subtract 1 and subtract 1. And then I'd be left with, let's just put this over here. This isn't confusing at all, is it? Let's see, tangent squared theta being by itself, it's secant squared theta minus 1. Hey, that's right there. Weird. So this whole thing is tangent squared theta, and that's honestly as simple as it gets. This is actually my final answer. Yes, me boxing that probably is a little confusing, but that's okay. And yeah, that's how the cookie crumbles. This is simplifying trig identities. It's not an exact science. There's multiple ways to skin a cat sometimes. The idea is that you're just working towards trying to make it simpler, and that's what you gotta do. Got to use some relationships like difference of two squares. We got to take some of these identities and we can actually manipulate them in ways that we can change them to help fit whatever situation we're trying to use them in. This is a very out of the box type of thing, so getting that out of the box thinking and pattern recognition is going to be very helpful. I can just tell you that it boils down to, if you've got nothing but no squareds or anything, just go ahead and just convert to sines and cosines, and that tends to work. Of course, number 5 didn't fit that bill. It kind of had a different idea, but that comes from different pattern recognition. But when you have these squareds, try to use these Pythagorean identities to your advantage, and that's the idea. We'll continue to practice that as we go along. And again, good luck with the state.